Hello roasters, thanks for joining me today. In the last edition of this Roasting with Roastmaster series, we looked at our original example of a completed roast with two data curves, bean temp and gas, and learned how to easily turn this roast into a roast profile. Then we looked at how we can easily tag that profile in a future roast and use the analyzer's targeting mode to stay on track with the reference curves that the profile gives us, and also how to manually log data to our new data curves that were created for us in the roast courtesy of the profile's curve templates. In today's screencast, though, we're going to talk about automatic data logging, where Roastmaster's data logging option does all of the data collection work for you and gives you a truly hands-free workflow. So let's see how this works. Once you enable data logging, the very first thing you need to do is to define the probes that you have attached to your roasters. And we do this by navigating to the probes library, and in the bottom toolbar we'll tap the plus button. And for this example we are using fidgets, so we'll tap fidgets temperature sensor. And here's our new probe definition. So we'll want to enter a serial number for the temperature sensor. So we'll tap serial, and this serial number is 342082. And port, this is on the first port, so it's port 0. And that's all we need for this. We can see that it is linked and getting a temperature reading. So we'll tap save. And we're going to use another probe on this particular roaster, so we'll define our second fidgets temperature sensor with the same serial number. And this one is port 1. Okay, this guy's linked, so tap save again. And our probe definitions are done. Now, once your probes are defined, you don't ever have to fool with them again unless you want to adjust the calibration offset for any of your probes. This is a one-time affair, so now that they're defined, all we need to worry about in the future is putting them to use. And we do this by simply binding a probe to a temperature reading curve in a roast. Now, if you have not yet begun using roast profiles, then that process would look something like this. You would create a new roast, then add a new curve, make sure that it is a reading curve, then tap the bind to field in the probe section. Choose your probe and tap save. And your roast would be configured and ready for data logging for that curve. You would just repeat this process for any additional curves that you're going to use in that roast. But if you do use profiles in your workflow, then the process is still the same. We just apply the binding to the curve template instead. So let's navigate to the roast from yesterday's screencast and look at the details of our Kenya profile. We'll tap the bean temp curve template and put that into edit mode and set the binding here. Now the interval field here is set at 15, so what that means is that every 15 seconds Roastmaster is going to record a new node in this curve. The probe readouts themselves, wherever you see them in the console or the analyzer, they're all live temperature data, and that's taken every half a second in Roastmaster. So whenever you see temperature readouts, you know that that is live real-time temperature data, but Roastmaster only samples nodes every so many seconds in an effort to keep your database size down and to keep the user interface and the screens as responsive as possible. So I typically run with this on 15. You can go lower or you can go higher, but I think 15 is a good round number and offers a good level of granularity without going over the top. And what happens now is that if we create a new roast and then choose this profile of Kenya, we can tap the console graph to select the data curve that was created for us in this roast from that curve template and see that the probe binding field in fact has carried over and that that probe is now available to us in this roast for data logging. So no matter how many curves you like to use when you roast, if you set all of their binding information in the curve templates details of your profile, then that information will be automatically applied whenever you use that profile. So the act of configuring the roast is truly a 1 or 2 tap affair. So I think now would be a good time in this series to set aside the sample data and take it up a notch and look at some real world data, some data that's more complex and that showcases how to use data logging in conjunction with curve events to create a new kind of roasting workflow. Now, we're not actually going to explore how to implement events in this screencast. And trust me, I tried it. It's 35 minutes long. So what I'm doing is splitting it up into 2 separate screencasts. But you will be able to see a glimpse of how they work and get a good idea of what they are. And then we'll learn how to implement them next time. Now, the profile that we'll be using in this next roast is called Pyrolysis Target 3. This is a profile that I like to roast with on my 1 kilo sample roaster, but unfortunately that roaster does not have variable heat, so the only means I have of controlling the heat in the roaster is via the damper. So on this profile, I'll track bean mass and exhaust temps. So I have both of my curve templates already set up and bound to the appropriate probe, and we're ready to go. So we'll create a new roast and tap Add Item, and then choose an item and select our Kenya pea berry, and then enter a weight of 2 pounds and tap Save, and then we'll select our profile. Then we'll save the roast and open the roast analyzer. Now, the first thing we want to check is to make sure that we're in profile targeting mode. Then we'll turn on the labels for curves so that we can see the temperatures next to each curve. And that's all that we have to do to configure this roast with just 2 taps actually. Via curve templates and profiles, we've configured this roast, and all of our reference curves for targeting are in place, as well as our data curves for data collection and all of their curve events, which we'll get into in the next screencast. So all that we need to do is wait for the roaster to come up to our charge temp, and when we're ready, press start. Now let's speed this up so that we can watch the whole roast unfold. Roastmaster's automatic data logging option, of course, is taking care of all of the data collection for us. We don't have to do anything on the iPad, just watch it all happen. And the analyzer gives us side-by-side temperature comparisons so that we can more easily stay on track with our reference curves. Of course, we could zoom in and out on this data if things get critical. But in this roast, we are monitoring bean mass temp and exhaust temp. And you can see the blue curve of the exhaust temp and where it peaks when I open up the damper to stay on track with my bean mass reference curve. And I don't really have any need for control curves. And when you couple that in with the events that are firing and letting me know what to do at certain temperatures, then we have a, in my opinion, more advanced profile setup where, you know, we can concentrate or at least multitask, I should say, while the roast is progressing. We don't need to be sitting there entering data. We just kind of keep an eye on things, keep the roast on track, and we are free to do other tasks while this is going on. And again, please join us in our next screencast where we will cover roast and curve events in depth and show you how to get up and running with them and the benefits that they can provide. Hopefully, though, in this one, you've learned how to get up and running with automatic data logging and how it can provide a much more streamlined and hands-free workflow, as well as make your roasting data much more accurate. Well, thanks for joining me today for this screencast, and please tune in for the next one to learn how to get the most out of using Roastmaster.